Okay, so this is the missing video 44. We'll call it video 45 though, because I have this order. 44 will make an appearance at some point, but later on. So anyway, let's do a quick review for your test. You're going to start your test today, but you'll probably finish it on Wednesday during block. So no fever with this video, but I want you to give the key points a good second look here. First thing, which is the biggest thing, is slope, which I will not say is slope. It's a rate of change. And on linear functions, so the straight lines that we do, the rate of change never changes. It's the same no matter what. So if this is the length of the line, like this, from here to here, this point to this point, it's got a certain rate of change, okay? But if I went from here to here, it's still the same rate of change, regardless, okay? So, for instance, if this was the line, the slope is 0 because it's horizontal. From here to here, it's 0. From here to here, it's 0. From here to here, it's 0. It's always the same no matter what 2 points you choose. Okay, so you're going to see it a couple different ways. I'm going to ask you to find the rate of change, not the slope, of points. Okay, so we'll just do this one together, and you can grab that one in a second. First step is write the formula down. y2 minus y1 over x2 minus x1. Make sure you have that written down. You're going to be using the slope formula for a really, really long time, so make sure you understand it. Second step is to identify the points by labeling. So this is x1, y1. It's the first x value I see, it's the first y value I see. Second x value I see, second y value I see. And then just plug it into the formula. So 4 minus, remember the minus is built in, okay? 8 over negative 4 minus a negative 3, okay? They both have to be, there's double minuses here, double negatives, because I have two negatives here. Top is going to be a negative 4, bottom is change, which is going to be a negative 1. Both the negatives cancel out, okay? So the answer is just going to be 4, okay? Or 4 over 1, but 4 is easier for us, okay? So negative 4, negative 1, bam. All right, try that one. We'll get back to it in a minute. Maybe, maybe not. Now that I'm thinking about it, I probably won't, but yeah, I might as well. Hopefully you paused me and tried it. 3 minus 6, negative 1 minus negative 1, negative 3 over change, 0. Ah! For those of you who have a good understanding of slope, did I even have to go this far? The answer is no, because I see that my two x values are exactly the same, which means that the slope is undefined, not 0, undefined. When 0 is in the bottom, it's undefined, which means the line, if I were to graph these 2 points, would be up and down. Up and down is undefined slope. Please don't ever say no slope. There's always a slope, even if it's undefined. And no slope indicates there's no problem, because 0 is a number. Cool. Hopefully we got that. Good. Whew. Second way you'll see it is from a graph. You can just count, right? It's rise over run, right? The y values over the x values. So this slope is going downhill. You know it has to be a negative slope, right? So I'm going to count. Negative 1, negative 2, negative 1, negative 2. Okay, so I know it's a negative 2 up top. 1, 2, 3, 4. Right? So negative 2 over 4 is going to be simply reduced to, or simplified to, negative 1/2. Bam, done. Okay? You could have done it with the points here if you wanted to, but I don't know why you would do that. Next way is a table of values. This is going to be challenging because it looks weird. There's 2 ways you'll see this. X, Y on the left, and they go across. If they go across like that, the X values are always the top values. X, Y going down, X always on the left, Y always on the right. This will always be the 2 ways that you see this. I prefer this way, but you may see this on a test as well. Same thing. Identify your values. In here, I'm not going to go through with this, but I wanted to see how you do this here. This is my first X value that I see. This is my second X value that I see. Here's my first Y value. Here's my second Y value. Then you plug into the formula. Now, the question yesterday was, do I have to do it for all of them? No, because remember how I said in the beginning of this video, on a straight line, which all these will be, the slope never changes. The rate of change never changes because that would not be a linear function. It would be some craziness. Right? So you can take the first 2 points, or you can simply take these points, this point here, and that point, or you can take that point and that point, or you can take that point and that point. It doesn't matter because it's never going to change. Right? I prefer just take the first 2. Don't make it more complicated than it needs to be. Here, x, y, same thing. This is the first x value I see in order. This is the first y value I see. This is the second x value. This is the second y value. Bam, done. Right? Throw it into the formula and make the formula work for you. Please don't forget your negatives. Slope is all about finding the rate of change, but really, in essence, mathematically, it's just subtraction problems. Know it. Okay, good. A couple other things you're going to see on the test. What is a relation? So we're going backwards now, right? Way backwards. A relation. You're going to need to know what a relation is. A relation is any set of ordered pairs. The only thing that isn't a relation is one specific point, because one point is just a point. It's not a relation. You're going to need to know what domain is. Right? Domain values are what? Good, x values. What's the domain of this table? 1, 2, 3, and 4. Okay. What's the domain of this table? 1, 2, 3, and 4. Range values. They're the y values. Okay, so domain and range. Domain, comma, range, if you were doing it as an ordered pair. What are the range values of this table? Good. 4.5 or 450, $9, $13.50, and $18. That's the range. Okay, good. You also need to know what a function is. A function is a relation. Okay, a function is a special relation that doesn't have repeating x values. You can't have more than one of the same x value. So the question is, are both of these functions? And the answer is yes, because there's no repeating x value here. Now what if I took this 3 out and made it a 4? That would not be a function, because now I have 2 of the same x value. Okay, you can't have repeating x values. Right? What if on this table, all of these were 5 for the y values? Would that be a function? Yes, of course it would be, because it doesn't matter what the y values do. It matters what the x values do. X values are more important when it comes to functions. All right. Let's see. What else is there? Oh, the graphs that look all weird and stuff. Okay, so they're called qualitative graphs. You're going to have to be able to identify what's happening. So for instance here, the bottom, the x values are always going to be time, or mostly time. Let's do this. We did this yesterday. Okay, so here indicates 0, 0. Okay, so I'm going to do like a baby being born. When the baby's born, it's not 0, right? When the baby's born, it's like, I don't know, 8 inches, 10 inches, well, I don't know, whatever. So let's just say it's this tall at birth. Over time, let's say it grows a little bit over time. The kid, the baby. Let's say the baby grows a little, not really a lot, and then kind of a little bit, and then a little bit. It stops, it stays constant, same height, which it's not possible. And then, phew, like over a course of a year or so, these are years, time in years, it shoots up, right? So it grows like, the baby grows like, I don't know, 6 feet in like 2 years, right? It's not possible, but just say it, right? And then all of a sudden it's like, I'm done growing, bam, okay? The straight lines across the horizontal slope, 0, it indicates that over time, the child is not getting any taller. It's not getting any shorter, right? That doesn't make sense. And the steep slopes indicate that over time, the baby or the child is growing up quickly or getting taller quicker, okay? So if I had something that looked like this, that means that child is growing at a constant rate over time, meaning every year the child would grow, I don't know what that would be, I don't know, a foot. So a foot here, a foot here, a foot here, a foot here, a foot. Every year it would be the same. So you have to identify the differences in all these changes. This is a long video. I didn't think it was going to be this long. That's the last thing now. So please make sure you watch this video. Ask me questions if you have any. And you'll be good to go. Have a nice day. Bye-bye.